Let's talk robots, or more specifically, simple commands for a robot. We've got a robot that's going to travel along our Cartesian grid. It's got three commands: move forward 1, turn left 90 degrees, turn right 90 degrees. Okay, those are our commands. We've got programs are made up of combinations of these three things. The robot will follow a program which will tell it a sequence of forwards, lefts and rights to take. Our starting program is just to go forward, and we generate a sequence of programs by saying, well, the next program is the previous one, it does the previous one, it turns left, it does the previous one again, then it turns right. So our first thing is, what is P2? Now, just to figure it out, right, let's say it's facing this way, that is P0. P0 is it goes that way. P1 then is P0, right, so let's just write this out, it's forward, which just means going that way. P1 would be P0 left, P0 right, which is forward, left, forward, right. As in it would go forward, left, forward, turn left, apologies, it will go forward, turn left, go forward, turn right. So it's facing that way, okay? P2 will be P1 left, P1 right. So P1 is forward, left, forward, right, then it turns left, then it goes forward, left, forward, right, and then it turns right. Okay? And that is my program. That is my program. Now, turning right, then turning left, we don't move. So in fact, turning right, turning left doesn't do anything. So that is just forward, left, forward, forward, left, forward, right, then right. Okay, if you pivot right, then you pivot left, you haven't pivoted at all. So that's what I've got there for number 2. Right, how many commands are there in Pn? Well, let's have a little think. All right, how many forward commands? So let's call that Fn, the number of forward commands. Well, how many are they going to be? How many forward commands? Well, let's see. How many forward commands are there in the next one? Well, you've got, that doesn't add any forward commands, that doesn't add any forward commands. So all you've got is you've got twice the number of forward commands in the previous one. Right? That's all you get. Now we start with 1. So because P0 is 1, P1 is 2, and we'll quickly see that P2 is 4. All right, we should quickly be able to see that Fn, the number of forward commands, is not 2 to the 0, is 2 to the power of n. Okay. Now, if ln is the total commands in Pn, let's get ln plus 1 in terms of ln. Well, ln plus 1 is what? Well, same sort of idea. We've got the number of commands will be the number of commands in Pn twice plus 2. So it's ln times 2 plus 2. Now, can we use that to come up with a formula for ln in terms of n? Now, I know a way to do it, but let's have a little think here. That is 2 times ln plus 1. So let's just have a look. If we're not sure, we can always look at a few. L0 is 1. Let's actually not concatenate these ones. All right, because the commands are there. So number is 4. The number of the second one is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will be 10. To get the next one, it will be 20 times 2. 20 plus 2 is 22. 3 plus 6. So where does that leave us? How about let's take 2 away from each of these. This looks like there's something on here. I'm always 1 away or so from a multiple of 2. For a multiple of... If I do that plus 2, if I add 2 to this, what do I end up with? L1 plus 2 is 6. L2 plus 2 is 12. 24. Ah. Okay. So a hint in the question does say, let's consider ln plus 2. Well, that looks like it's 3 times 2 to the n. Is that right? Because that's 3 times 2, 3 times 2 squared, 3 times 2 cubed. So I'm going to say that ln is 3 times 2 to the n minus 2. Those of you that study further maths, that is a recursion relation that we can also solve, but that was not the aim of the game here. We were trying to see if we could spot the patterns here. Now, there is a hint that I hadn't put in here, that to consider ln plus 2, which is where we get to there. Now, if the robot starts at 0, 0, and it's facing the positive x direction, which way is it facing after Pn? And this one's a bit of a trick, and I'm going to tell you the same way. It's facing the same way. Why is that? Well, we start with going forward, and any time we add in, we change this, we're going to turn left as many times as we turn right. So every time we build this, we've got as many left turns as we do right turns. So what that means is overall, you will have faced 90 degrees left and then right the same number of times, which will cancel out. So you are facing the same way. The real meat and potatoes down there. Hope you enjoyed that. As always, I certainly did. Some interesting stuff going on there. Had to think for a second. Don't forget to drop us a comment, a like, a subscribe, hit the notification so that you don't miss a second of me rambling in front of this whiteboard. Also, if you do have A-level maths, A-level further maths coming up at the end of next year, or you're going along that journey in year 12, please do consider clicking the link below. See the MyEdspace A-level maths and further maths courses. They could be a really good fit for you. You get to hang out with me, you get to hang out with Neil of Neil Does Maths. We will get you ready for your exams throughout the year. Go check it all out, all the information in the link below. If you do, if you don't, I will still be here next time, so do come tune in for some more maths. See you soon.